Today's lesson is going to be on making predictions and experimenting with spinners. Let's look at our first problem here. Which is more likely, spinning a 2 on spinner J or on spinner K? Well, we need to make a prediction. So first off, I'm taking a look at spinner J, and I can see that the area for 2 isn't taking up too much of the circle. So we have 4 sections in the circle altogether, and one of them is taken up by the number 2. If I look over at spinner K, where the 2 is, same thing. I have now 6 sections on the circle altogether, and I see one of them is taken up by the number 2. Now, the area on spinner J over here is much larger than the area on spinner K where the number 2 is located, even though the circles are the same size. So my prediction is I think it's more likely to spin a number 2 on spinner J, just because the number 2 is taking up more area on that circle. Now that we've made a prediction, we need to test our prediction by doing an experiment. So we have the 2 spinners, and we can spin them the same number of times. In this case, we'll spin them 10 times each, and then we can collect the data using the tally charts. So we can see one side of the tally chart says 2, the other side says not 2. So anytime we spin a 2, we would put our tally over here, and when we spin not 2, it would go over on the not 2 side for both of the spinners. After spinning both of our spinners 10 times each, here are our results. We can see over on spinner J that we spun a 2 a total of 3 times. And on spinner K, we spun the number 2 a total of 4 times. Well, that doesn't really match our prediction because we predicted we would be spinning a 2 more times on spinner J. But that's not actually what the results are showing us. That's okay. Sometimes that happens when you do a probability experiment where your prediction doesn't line up with the outcome of the experiment. Sometimes it's a matter of maybe redoing the experiment. Sometimes when we repeat an experiment, the results will change. Sometimes we might not have given it enough spins. Maybe if we added a bigger number of spins for each spinner, such as 20 or 30, we may find that the outcome is different as well. So if you see this happening, that would be a suggestion. Either repeat the experiment with the same number of spins, or repeat it again and use a larger number of spins. That will help it to be a little more accurate. For our purposes, I have decided that I am going to repeat the experiment, but this time I am going to spin each spinner 30 times because I think that will give me a more accurate result, and hopefully my results will then match my predictions. Here are my new results after spinning each spinner 30 times. We can see on spinner J that I've now spin number 2 8 times. And when I did spinner K, I spin number 2 5 times. Now my prediction actually lines up with my results. I did spin a 2 more often on spinner J. This is because now I've added some spins, which makes it a little more accurate because I have enough spins to have a reasonable, practical, and meaningful experiment. Anytime you do that, you're going to find that your results turn out a lot better. So in conclusion, we conduct probability experiments to collect data that can be used to describe or to compare probabilities. But we have to keep in mind that experiments must have a reasonable number of repetitions for the results to be meaningful. Just like we saw with our spinner experiment, when we had less spins, we didn't have the outcome we were expecting. When we added in more spins and repeated the experiment, then our predictions matched our outcomes.